Hello, fellow builders and engineers. I'm Yogesh, and today we're diving into a topic that's truly a matter of life and death in engineering safety critical dimensions. Engineering drawings are more than blueprints. They're the language of making things, and some numbers on those pages are absolutely vital. These are the dimensions you cannot get wrong. If you do, the results can be catastrophic. It's not just about making parts fit, it's about making them safe. Think of a 1mm error on a bookshelf, it's a wobble. On an airplane's landing gear, it's a disaster. That's why we have a formal system to flag these crucial measurements. A way for designers to say, pay extra attention, lives depend on it. In this video, we'll unpack what makes a dimension safety critical, how to spot them, and how to mark them so everyone is on the same page. This is about more than rules. It's about responsibility and precision. In engineering, the small stuff is often the big stuff. So grab your calipers, let's get started. So, what are safety critical dimensions? Simply put, they're measurements that, if out of tolerance, could cause failure and endanger lives. These aren't just any numbers, they're the backbone of safe design. For example, in cars, the thickness of a brake rotor is safety critical. Too thin, and brakes can fail. The diameter of a bolt hole in a steering knuckle? If it's too large, the bolt could shear off. In aerospace, the wall thickness of a hydraulic line or the spacing between turbine blades, if wrong, can lead to catastrophic failure. Every one of these dimensions is marked and inspected with extreme care. In medical devices, the internal diameter of a drug pump tube or the thread profile of a bone screw can mean the difference between life and death. Even a tiny error can have fatal consequences. These dimensions are the ones engineers lose sleep over. They're identified, marked, and checked with almost religious scrutiny. There's simply no room for error. Whether it's a car, a plane, or a medical device, safety critical dimensions are everywhere. They're the silent guardians of our designs. Why mark safety critical dimensions? Because focus matters. A single part might have hundreds of dimensions, but not all are equally important. Marking the critical ones tells everyone, machinists, inspectors, where to focus their best efforts. It's a red flag. Handle with care. For these features, machinists use more precise tools, slow down and double-check. Inspectors know these require 100% inspection, every part, every time. This creates traceability, so if something fails, you can track exactly what happened. Marking is also a legal and regulatory requirement in many industries. It proves you've thought through the risks and put controls in place. It's not just good practice, it's professional ethics. Marking safety critical dimensions is a cornerstone of public trust in engineering. How do you identify a safety critical dimension? Start with the part's function. If a feature's failure could cause the system to fail dangerously, it's critical. Look for features that bear heavy loads, like the diameter of a shaft or the wall thickness of a pressure vessel. Use tools like finite element analysis to spot high-stress areas. Assembly fit matters: 2 press fit pins, piston clearances. If the fit isn't right, things can fall apart or seize up. Always check industry standards and historical data. Organizations like SAE and ASME have codified decades of experience. These standards often highlight which features are critical. Don't reinvent the wheel, learn from past failures. Identifying critical dimensions is detective work, blending analysis and experience. It's about asking, if this goes wrong, what's the worst that could happen? That's how you spot the numbers that matter most. Once you've found a safety critical dimension, you need to make it obvious on the drawing. Engineering uses standardized symbols, most commonly an elongated oval or stadium shape around the dimension and its tolerance. Sometimes you'll see an inverted triangle or a diamond, depending on the industry. The key is consistency and clear documentation. define your symbols in the drawing notes. Often, a note will specify critical characteristic, 100% inspection required. The symbol grabs attention. The note spells out the requirements. Remember, the tolerance is just as important as the base number. Tight tolerances mean tight safety margins. Marking both ensures everyone knows this feature must be perfect. It's the universal language of "don't mess this up." Marking a dimension is just the start. Inspection is where safety is guaranteed. Safety-critical features demand 100% inspection. Every part, not just a sample. For simple features, a digital caliper or micrometer might do. For complex ones, a coordinate measuring machine, CMM, is used. CMMs create a 3D map of the part, measuring with extreme precision. Every measurement is logged, tied to the part's serial number, creating a traceable record. If a part fails years later, you can check exactly how it was made. This isn't just paperwork. It's the backbone of quality and legal compliance. Inspectors handling these features are highly trained and know what's at stake. Out-of-spec parts are quarantined and reviewed. They never move forward until deemed safe. Inspection and documentation are the firewall against defects. Let's see how this plays out in real industries. In cars, airbag systems rely on critical dimensions for safe deployment. Wall thickness, vent hole size, all checked and x-rayed. In aerospace, even a simple bolt's core diameter and thread profile are safety critical, ensuring the plane stays together. Water treatment plants depend on valve seat and seal dimensions to prevent leaks of hazardous chemicals. In nuclear power, pipe wall thickness is monitored for decades. Any thinning is a potential disaster. Every one of these features is marked, measured, and documented. The stakes are high. Public safety depends on getting these numbers right. Across industries, the process is the same. Identify, mark, inspect, and document. It's a universal discipline. Safety-critical dimensions are everywhere, quietly keeping us safe. To sum up, safety-critical dimensions are the unsung heroes of engineering. They're the numbers that keep our world running safely, from cars to planes to medical devices. Identifying them is a designer's duty, analyzing function, load, and fit. Marking them clearly sets the safety chain in motion. Rigorous inspection and documentation build a firewall against defects. This is what separates professional engineering from casual making. It's a culture of quality and responsibility. By mastering this discipline, we protect lives and build trust. Every precisely marked and inspected dimension is a commitment to safety. Now, go build something great and build it safely.